Αγαπητοί κύριοι, κυρίες, θα προχωρήσουμε στην επόμενη σύνοδο, η οποία θα ασχοληθεί με το DataPorts Project. Όπως είπα πριν, επειδή οι παρουσιάσεις αφορούν σε ένα ευρύτερο κοινό, γίνονται στα αγγλικά, θα μεταβώ και εγώ λοιπόν στα αγγλικά, by welcoming everybody participating in this second interactive session, which will be about opportunities and challenges for the seaports of the future in the 5G and beyond era. We will see several aspects and innovations coming from the DataPorts EU-funded project. I would like to welcome my colleague, Dr. Christos Gizelis, with many thanks to Christos and to the other speakers for their kind support in order to organize this session. And Christos will also be the chairman of this second session. The stage is yours.
Thank you, Yannis. It is a great pleasure to be here. And I would like to thank you on behalf of DataPorts project for giving us the opportunity to present our research activities in this year's Infocom conference. DataPorts project is not a 5G project. However, 5G, IoT, and other network technologies could be the backbone in order to transfer and share data, data that are considered are resources for data-driven platforms like the one that is proposed by the DataPorts project. Something's wrong with the... No, it doesn't. Okay. DataPorts project, another EU-funded project under the Horizon 2020 framework with a 3 years duration. We just received a 3-month extension. Currently, we are reaching the final stage, 4 months left, a budget around 6 million euros, 900 person months, and 13 partners from all over Europe. Industry partners, Porto, Pilot, entities, research centers, universities. So we together create a cluster that combine all the skills needed for this research. So what DataPorts project is about? It's about creating the seaports of the future, creating ports, actually making ports from interconnected into smart and cognitive by providing a secure environment in order data to be aggregated and shared from and to different sources. And that will have a port community to benefit from this data exchange. How we plan to achieve this? By creating a distributed architectures data-driven platform that is capable for data processing, data aggregation, acquisition, and of course under a secure environment, and also being compliant with the data protection and European regulatory environment. Having blockchain as the main backbone technology to ensure security and trust. We ran 3 use cases, 3 pilots, one in Valencia port with several scenarios like tracking of transport operations, data sharing and analytic services for port authorities, sharing verified gross mass. Another use case in the Thessaloniki port pilot with services for container pickups, passenger facilitation, and statistics, but also run a global scenario use case with reference in tracking containers and port management systems. Why we do all this in DataPorts? Because access to information gives answers. Answers for what? For better customer insights, new forms of collaboration between the stakeholders of the seaport ecosystem. Also, answers will improve decision-making to the decision owners, the key stakeholders, and of course expand the customer base of the entities, of the companies around the seaport. And this gives opportunities for businesses, for citizens, for research centers, and public bodies. Why? Because it creates a new data-driven market. Citizens or data providers can have full control over their data, gives access to services. Research community can have access to data and provide new services. And public bodies using this platform could have better governance services, better digital services, or even real-time statistics. This is how we imagine the seaport ecosystem of the future. It will include industry end users, technology providers, data market actors, and more are more than welcome to join. We envision a seaport ecosystem expanded with more stakeholders than the ones that are already known. Cargo hauliers, port terminals, transport operators, cargo owners, other data-driven platforms, custom authorities, even culture, museum authorities, commerce associations of the local region, railway authorities. All these could be come and create an ecosystem around the seaport of the future. And data will be what they will bind them. At the beginning of the project, we ran a survey to identify the market needs. And we saw that the community is ready to be on board the seaport transformation. We see a great interest from the shipping and maritime community, actually a major actors in this attempt. Universities and research institutions show a great also interest because they have a thirst for data, and this data will help them, will assist them validate their research, and port authorities could be the selling point for them. So it's a new economy also for the academia. Telecommunications, of course, data sharing could rely on telecoms. ICT services, cargo logistics, software houses, and all this you can depict from this picture. Another feed we had from this survey is why all these entities have an interest in DataPorts and in data-driven platform in general. They need data, and they need them to process safe conclusions, so decision-making for research purposes, and to better map their customer needs. So these are considered the key elements that were considered in the last 3 years of DataPorts. And of course, accuracy, availability, and up-to-date are what is important when using data. And all these parameters are also covered within DataPorts project. especially accuracy, availability, data being up to date, and the easiness to migrate those data. And all this based on the components, the tools that created in the DataPorts platform. And more about this, you'll hear from the next DataPorts colleagues. Some of the achievements so far. We managed to create specifications and match the existing ones of the industrial platforms. We create a DataPorts architecture where it could be the baseline for the future of the seaports. We create new business and exploitation and innovation strategies. And all details about this can be found in our website. So this is it. I would like to thank you. If you have any question before we pass to the next speaker.
Thank you so much, Christos, for this global presentation of the DataPorts project, giving all expectation and innovations coming from the project. Just a general question by my side regarding the maturity of the market related to the innovations. You mentioned that there is strong interest. How, according to your expertise, how easy you find this transformation by taking into account, let's say, the outcomes of the project and the interest of the market actors, because it's very important. Just a comment on that, if possible.
The market actors are there. The need is well known. The stakeholders, in some cases, are very skeptic. Shipping and maritime sector do not make very fast moves forward. However, we have a consortium with strong technology skill sets, and we have managed to create tools that will help and ensure security and trust. So even that slight objection of some stakeholders, I'm sure that we'll overcome very soon.
Thank you so much.
Thank you. Okay, thank you. Now it's time to welcome a fellow data porter representing Thessaloniki Port Authority, one of the main pilots of DataPorts, Mr. Grigoris Dimitriadis. Grigoris, it's great to have you.
Hello. Hello, everyone. First of all, I would like to thank OT for inviting us to this event and giving us the opportunity to talk about DataPorts from our point of view. Yeah, I'm Grigoris Dimitriadis, as Christos said. I work in the ICT department of the Port of Thessaloniki, and I'll give you a brief overview from an industry partner perspective of the participation to DataPorts. So shall I share my screen? Can everyone see it? Can I have some feedback about if my presentation shows?
Yes, we can see your presentation and you as well.
Okay. And me as well. All right. I'd rather not. Anyway, so first, a few things about Port of Thessaloniki. As most of you may know, it's the second largest port in Greece. It's located in Thessaloniki in the north. THPA is the acronym that we use, so you'll see it throughout the presentation being used. Thessaloniki port has a great hinterland connection and is considered to be a gateway port to the southeast and central Europe. It occupies a total space of 1.5 million square meters and spreads across a length of 3.5 kilometers. And it's literally adjacent to the city, which is sometimes both good and bad, actually. Well, the port includes 6 piers. You can see them in the photo. It's got open and indoor storage areas suitable for servicing various type of cargo. You can see at the bottom, we handle containers, dry bulk, liquid bulk, general cargo, and also servicing passenger vessels and cruise ships. You can see from the pie chart, it's quite obvious that most of the revenue is generated from the container terminal. It's about 66%. And the container terminal, together with the conventional cargo terminal, handling all the bulk and general cargo, they make up about 97% of the port's revenue. And we recently opened a dry port in Bulgaria to service the hinterland for logistics issues. Now, as mentioned, THPA is one of the pilot ports in DataPorts. And in the context of the project, a number of use cases actually are being implemented. I'm just going to briefly mention them here. It's the corridor or container pickup use case, which I'm going to analyze mostly in this presentation. We also have 2 use cases featuring statistics and predictions, which involve fusing data generated from various THPA systems and applications to generate useful statistics, operational statistics, and KPIs. We have 2 use cases that also fuse data, but this time we're giving emphasis on mobility and mostly combining OTs, mobile subscriber data, and also arrivals of passengers and cruise ships in the port to produce heat maps and predictions on movement of people and vehicles around the port area. And finally, we have 2 global use cases, as they are called. They showcase the use of IoT devices, but not as strict. Posidonia Operations is an application that feeds data to the DataPorts platform, and it uses an ICE antenna to build some intelligence on top of it, because an ICE antenna just transmits raw vessel location data. And Posidonia, by using cartography and combining cartography and the vessel data, transforms basically this raw vessel location data to events that are meaningful to the port in real time, like, for example, the ship has just moored or docked or undocked and all that. And finally, the other global use case is smart containers from TrackSense. It uses IoT devices mounted on containers. They are sensors mounted on containers, and well, they also transmit data about themselves, and they allow parties to follow the location of a container. Now, about the main use case, we'll call it main because it's the one that heavily features the blockchain component, which is central to DataPorts. Well, with this use case, the goal was to support, sorry about that. Right. The goal was to support the THPA ecosystem stakeholders and to better organize and manage the container pickup, with emphasis to land gate access, meaning the trucks arriving to the port in and out for traffic issues. And the way to achieve that is that the blockchain application that is being developed will facilitate secure information sharing between THPA and the supply chain related parties, namely shipping agents and tracking companies, about concerning the business cycle of the electronic request to pick up a container. So for this scenario that was implemented, we identified three involved parties, the entities. One was obviously THPA as a company. We just call him a terminal operator, somebody from THPA. Well, they need to have a unified information from a number of systems so as to verify that all relevant paperwork is in place and provide a container release order. A shipping agent, they need to make arrangements and all the relative paperwork for picking up the cargo. And the tracking company that needs to be timely informed for the container pickup. Now, this is a sketch of how the solution is structured. We can see that the three mentioned involved parties, THPA, the shipping agent, and the tracking company, all interact with the local blockchain instance or node, which in turn interacts with the DataPorts platform and its components, and also with THPA infrastructure. So this is all centralized and overseen by the blockchain component, a major part of which is the data governance, which you see on the scheme, and you'll hear more about from the next presentation by Mr. Zerzalidis. So roughly the process is this. A shipping agent, well, they deal with a container, and once it arrives and it's unloaded from the vessel, they have to arrange all the paperwork related to the container being able to leave the port and being picked up. Ourselves, the Port Authority, will have to verify that all relevant paperwork is in place, and we approve the container discharge. But at the moment, before DataPorts, without having any further involvement. That means that the shipping agent has to make an arrangement with a tracking company about the pickup of the container once it's allowed to leave. And the THP is not part of this arrangement. So the DataPorts platform will introduce the blockchain component that's going to store the request. It's called the container release order, where all the life cycle of this, the container release and pickup, can be followed by all involved parties. So this is the core thing I've been referring to. As I said, it's an acronym for container release order. It is an electronic message following XML and EDIFACT standards. This is actually one of a set of similar XML messages that have been defined in the maritime industry, such as COPRAR or COARI, that they describe various operations like loading a container or announcing a vessel arrival and others. These are used for electronic exchange between systems without people have to call in the phone or something like that. So in a courier message, as you may get a glimpse of, the shipping agent specifies the container that they want to pick up. Small parenthesis, each and every container is actually marked with a globally unique identifier. They're not just nameless boxes going around. And also in the courier message, they define also details about the container, like which vessel it was unloaded from, its cargo, its size, the weight of the cargo, what's the contents inside it. And in the message, they also specify when the request gets approved, which tracking company will come to pick it up, because shipping agents are not tracking companies; they collaborate with people that have the trucks, actually. Right, this request gets stored in the THPA systems. Well, obviously through the blockchain component, and it has to be checked by THPA staff to see if everything is in order. For example, customs clearance or nothing pending in payments, or any issues that the box may have to be able to leave the port. And if everything is okay, then THPA approves the request. And when it does that, a unique permit ID is generated. Now, this unique permit ID is obviously tied to the specific courier request that was made by the shipping agent. Now, through the blockchain component, this permit ID is communicated both to the shipping agent and that sent the request, the courier request, and the tracking company that will pick up the container. Now, in THPA, in order to optimize the flow of trucks in our premises, we have an application in place. It's called the Truck Appointment System, or TAS, as we call it. And trunk companies and drivers have to use that to book slots where they set a time window when they will arrive to the port and either deliver a container or pick up one. So the tracking company, when accessing that system to make a booking for the pickup, they specify the container to be picked up and also enter the generated permit ID that I spoke earlier. Now, the blockchain component, since keeps track of all the steps, it can notify anyone, and also make sure that the given ID container ID, sorry, in that booking matches the expected permit ID. And if all goes well, then the tracking company receives a confirmation for a successful booking, so the truck can proceed with coming to the port at the defined time slot, of course, to pick up the container. So this is the flow I just described. You can see the order. Shipping agent sends the courier request. THPA receives the request. Everything is okay. Number 3 issues the permit ID. And well, the next part is the nice part. That number 4 is actually forked. Both the shipping agent and the tracking company get notified of the permit ID, so they know that everything's all right. And using that permit ID, then the tracking company, number 5, sends a request for a booking, which is received by THPA. And if everything is all right with the booking, then the booking is accepted, and there is a time window defined for the truck to arrive to the port and actually pick up the container. So this is the scenario that this use case actually implements. So some benefits from that use case and from the participation of THPA in DataPorts in general. We have safe and secure transactions and data exchange, immutable single source of truth for all transactions. These are actually buzzwords that really hint to the blockchain component. We have a transparent business cycle of container discharge, and with that, THPA ecosystem stakeholders can optimize their processes. We have a platform that contains and combines data from different sources and entities. And through all those, we have an increase of operational awareness, reduction of time loss through optimized use of resources. So that was it from my side. Thank you very much again for inviting us and having us, even online, not IRL, sorry about that. So if there are any questions or...
We don't see any hands raising from the audience here. Grigoris, thank you very much. You very well bind the business need, the business cases, and the technologies that used in DataPorts project. So thank you, even if you couldn't be here with us today. And
logistics issues, sorry about that.
Next time.
I was honored to be invited though. Yeah, thank you very much for the participation once again. Good morning from me.
Have a good day. So it's time to become more technical. So I would like to invite my colleague from DataPorts, Alexandros Zerzelidis from CERTH ITI.
Μπήκα κατευθείαν στο κλίμα της αγγλικής, της παρουσίας στα αγγλικά. Αυτό είναι, με αυτό μιλάω. Ωραία, ωραία. Ευχαριστώ και εγώ πάρα πολύ. Thank you very much for the invitation and for the opportunity to present our work here. It's a great venue, and we're glad to be part of all the projects that are being presented. My name is Alexandros Zerzeridis. I'm a researcher, software engineer at CERTH, or EKETA in Greek, the Center for Research and Technology, which is situated in Thessaloniki. Today I'm going to speak about the data governance component of the platform, which makes heavy use of the blockchain technology that has already been mentioned as part of the local use case. So let me start. So data governance is a mechanism that enables the enforcement of access rules to business data assets in a transparent, verifiable and non-reputable way. And here, when we talk about business data assets, we mean various data sets provided by various organizations of the maritime sector, which can not only be ports or tracking companies or shipping agents and so on, but can also be telecommunications companies or other partners of the general ecosystem of the port, like the municipality that the port belongs to, and so on and so forth. Various data sets. However, all these data sets, what they have in common is that they provide some value to the port's operations. So they are needed as part of some analytics that is being done, or some aggregation of data to produce some valuable result. And data governance increases the confidence in the registered data, because with data governance we know who registered the data, we know the metadata of this data, we can describe the dataset in a non-reputable way, let's say. I mean, the provider of the data gives the description, gives them the data, and everybody is certain that this is the case. And also this ensures data sovereignty, which means that the provider can be certain that his or her data will not be appropriated by some other entity. The aim of including data governance in DataPorts is to provide a secure platform for defining data sharing rules, and in trying to, in the beginning of the project, in trying to figure out what would best suit this endeavor, it was quickly realized that blockchain technologies is a very strong candidate for this type of framework, and the reason is that there are the features that blockchain offers are easily adapted to our needs here. So it's easy to define data ownership within a blockchain network, and we can easily have an agreement between the participants on the data distribution policies, which is the key issue of data sharing. The features of blockchain that make this make it so attractive are summarized. I mean, some of the main features, let's say, that support what I said. are summarized here. So we have a shared ledger that is the basis for everything. This is an append-only system of records, which is shared across the network. Every participant in the network has a copy of this ledger, and no one can alter this ledger by themselves. Any attempt to alter it is detected by the system itself, and it's rejected. This main feature offers full provenance, so we know every transaction, where it came from, when it was done. We know the full the entirety of the transaction's history. It offers non-repudiation, so nobody can later say that we did not do this or that. It's clear who did what. It offers transparency and traceability, and it's a single source of truth for everything that goes on the network. The second technology on the top, on your top right, is the smart contracts, which are business terms to which all participants in the network agree, that are encoded as computer programs. So whenever there is a transaction going on, there is a program, a smart contract, which is a program that is called to carry out this transaction. So every time a particular transaction happens, it happens with the exact same way, with the exact same rules that were agreed upon at the start of the network, and there is no way that this contract can be altered. Again, the same as with transactions, any alteration will be detected and rejected. Unless, of course, there is a consensus. That's the main feature below the smart contracts, which is a critical number of participants agreeing that a certain thing should change. And there are various algorithms that can be used for consensus. The main idea is that there's always a threshold above which decisions are valid. So if, let's say, some protocols might need 100% participant agreement. So all participants must agree on a change for it to be valid. Or there could be a 50-50 rule, or whichever other percent is suitable for the situation. This consensus idea is also what drives transactions. So for transactions to be passed on and encoded in the ledger, they have to be also agreed upon by all participants based on a consensus algorithm. And finally, we see that the main feature is privacy. All transactions are secure, authenticated. There is a built-in identity mechanism. Every participant has a unique identity within the network, so everybody can be certain that a transaction was made by this or that participant and no other. And transactions happen within a channel, which is a group, let's say a sub network within the network, where participants from a certain, let's say, consortium have their transactions. On a given network, there might be tens or hundreds of channels. So a channel is a way of ensuring that the participants will have their own space, let's say, within the network to to carry out their transactions, and you can even have even more privacy by having private data on a channel, but that might be getting a bit too technical. But privacy is the last of the main features that I want to talk about. Now, when we talk about the blockchain in the business process, it's useful to see what came before the blockchain technology, what was the state of affairs before the application of blockchain, and what happens after we apply blockchain technology. So, before the introduction of blockchain, we see that that each participant keeps their own ledger. These ledgers are updated separately, so it's expensive to keep them in sync because everything is duplicated, and also there are intermediaries adding margin for their services. So more complex, more expensive. It's also more inefficient because the business conditions, the contract that I was mentioning as part of the blockchain, which is there, it is a computer program. In any case, the business conditions which must be there in order to have any type of business network are duplicated for every participant, so this is quite inefficient. And it's also vulnerable because if one of the points that make up the business network fails, for example, if a bank system is compromised, the whole business process suffers from that. Now, in the case of blockchain, we have a solution that is comparatively inexpensive, since there is only one conceptual ledger. Each participant has to set up its own peer or peers. These are nodes, computers participating in the network, but that's done in the beginning once, and you don't need any special, let's say, maintenance for it. Not more than you would need for any server that you might have, for example. So it's set up once, and it participates in the blockchain network, and that is comparatively inexpensive than having to rely on external systems that could possibly fail or be compromised, and so on and so forth. And also try to it's inexpensive in the sense that here you don't have to try to sync your ledger. It's automatically synced because of the way the system is set up. Cryptography. 3 more minutes. Cryptography is used to ensure the network participants see only their part of the ledger. And we have provenance, immutability, and finality. The maritime has certain challenges that come with that domain. Data are in silos, information is exchanged in a bilateral manner. Processes are time-consuming. This is mostly manual in nature because of the nature of the people involved in that. Some of them might be port workers. They might not have any, special affinity with technology. So many of that work is manual. Much of that work is manual. So the impact of blockchain in maritime is quite big. And we can see in general, I won't go into much detail here, but in general you can see that we move from a mesh of interconnections to one big network of strictly defined relations and well-defined relations. The position of the data governance platform in the DataPorts platform is the red boxes up there. They're the ones that data governance is the framework that analytics and data process services use in order to get to read, let's say, the permissions that each user has on a certain data set. So somebody wants to use a data set for analytics. Okay, what's that person's permissions on that? Does he have the permissions to read the data set to use it for analytics? If yes, data governance says it's okay, and the process continues. Same for data processing services, which are the ones that actually read the data set from its original source. The technology we use are Hyperledger Fabric for the blockchain network, the Fabric SDK for Node.js, the storage is CouchDB, and we write smart contracts in the Go language. The architecture is a classic Hyperledger Fabric architecture with the channel in the middle. You have provider, consumer, and organizations using the channel, and also the other DataPorts platform components also using data governance, as I mentioned earlier. And you have the two ports, THPA and the Valencia Port Foundation, the Port of Valencia, that are the main the main constituent parts of the network. So they have their peers, ordering service, and certificate authorities, and they also provide, through them, external organizations can get access to the network. And this is the last slide. As far as the verticality, let's say, of the solution goes, we have on the bottom we have the Hyperledger Fabric with the ledger and chain code as the basis, as the back end. Then we have our middleware built in Node.js using the Fabric SDK to talk to the chain code, and also presenting a REST API to the various front ends that might be. And the front ends are what the users use to get dataset metadata, to get and define access rights on datasets, and so on. And I think I will stop here. Thank you very much.
Thank you very much, Alexandros. If there is any question.
Just a general question about the implementation and applicability of blockchain technologies. In the specific example, do you face any difficulties regarding the implementation, or apart from the technical implementation, are there any financial constraints, or we may say it's a normal situation, a usual example of implementation of these technologies into a wider framework to serve the specific aims of the DataPorts project?
Okay, the framework itself is open source, so there is no, with respect to its adoption, there is no economic setback, let's say. Using blockchain technology could be somewhat daunting for smaller companies, because, as I said, they have to set up a peer and in order to participate to the network, and that could be technically challenging for a small company. So they would have to do it through a technology provider, let's say. For example, CERTH. As we're doing with THPA, with the Port of Thessaloniki. But I think these are, this is something that can be overcome very easily and is overcome in this situation because there are partners, there are entities that can provide this sort of technological help, let's say.
Thank you, Alexandros. Now it's time for the last presenter, Mr. Achilleas Marinakis from NTUA ICCS.
I would like to thank you for the invitation and the opportunity to talk to this conference. My name is Achilleas Marinakis, and I am a research engineer from the Institute of Communication and Computer Systems, which is affiliated with the National Technical University of Athens. I am going to present the data processing and interoperability services that we implement in the context of the DataPorts project. This is the overall architecture of the project. It is the same picture that my colleague Alexandros showed before, and with red color are highlighted the functional components that compose the data processing services layer. These components are the semantic interoperability, the data access, and the data abstraction and virtualization. All these components are going to be analyzed in the next slides. Starting with the semantic interoperability, its scope is to define an unambiguous way to interpret the data that are being exchanged between computer systems in order to simplify the reuse of data within the smart sports domain. One of the lessons learned during DataPorts is that enabling interoperability is a very difficult task, simply because different organizations and stakeholders within the smart sports domain do not follow a common standard. Instead, they have their own vocabularies with poor definition of semantics or no semantics at all. In order to facilitate interoperability, we put a lot of effort to try to describe and model the ports data in a systematic and standardized way. The first step of this data modeling process was actually to identify and analyze the different data sources that we had to deal with and integrate in the DataPorts platform in terms of the meaning and the format of the data. And secondly, we carried out a state-of-the-art analysis and review of the existing ontologies and vocabularies that appear in the literature for potential reusability. The tangible outcome of this data modeling process is what we call the DataPorts Common Data Model, which I will present now. Some information about the Common Data Model. It is based on 5-ware Smart Data Models guidelines and is also fully compatible with other European standards and initiatives. So we have the root, the smart sports domain, which is then divided into many subjects, each one of which contains many entity types. This is the complete picture of the DataPorts common data model. With a blue color, you can see the different subject, and with a green color, you can see the different entity types. The representation of each one entity type is described using JSON schemas. After defining the DataPorts common data model, the next step was, the next challenge was actually to connect heterogeneous data sources to the DataPorts platform. For that reason, we have implemented the so-called agents, which are scalable software components that retrieve the data from the data sources, translate them into the DataPorts common data model, and finally make them available to the processing layer via a unified API. Two types of agents have been developed. The on-demand agent, which is responsible for retrieving historical data, which is depicted in this figure, and the public subscribe agent, which is responsible for providing real-time data. Τώρα, καλύτερα. Ωραία. Thank you. Once the data are the translated and once the data, the translated and harmonized data are available by the agents, the next step was actually to offer this data as a service, putting special emphasis on the quality of the data and the quality of service. This is achieved through the data abstraction and visualization middleware, or briefly DAV, which let the application developers simply define the content and the format of the data they need, and then just rely to the proposed middleware in order to retrieve those data regardless of the underlying technical complexity. As can be seen in the figure, DAV is composed by 3 subcomponents, which will be analyzed in the next slides. The first subcomponent is the preprocessing and filtering software, which is responsible for the initial preprocessing, cleaning, and filtering of the incoming data. Typical preprocessing techniques are being performed at this stage, like removing all the white spaces from the string values, remove the duplicate records, filling the missing values, or detecting outlier values. The goal of this subcomponent is to improve the quality of the data, which clearly affects the performance of the data-driven applications that are built on top of the data. The next subcomponent is the virtual data repository, which is actually a distributed infrastructure to store this preprocessed data. It is a data lake that is capable of upscaling and downscaling in a fully automated way based on the incoming workload in order to achieve a resource optimization, low response times, and high availability. Finally, The next subcomponent is the virtual data container, which is actually the interface between the middleware and the data consumers, which in our case is the analytics component of the DataPorts platform. Its role is to further process, filter, and then serve the data as data points by applying specific filtering rules to the datasets, and then transform the data to the desired format like JSON, Parquet, or CSV. Some more details about the filtering rule system that we implement. Its goal is twofold. On one hand, to enable the consumer simply retrieve only the portions of the data they are interested in, and thus to minimize the processing and the network workload. And on the other hand, to detect and remove obvious wrong values, most probably caused by sensor malfunction, like for example, abnormal temperature values. The syntax of the filtering rule system follows the subject operator object syntax and is kept simple on purpose so that the rules can be specified not only by data scientists or experts, but also from users with limited or no technical background. And in the end, what we actually offer to the data consumer is a common access layer through which they can simply define queries in the form of rules in a unified format, and then they rely on the VDC designer, the provider of the data, to develop all the necessary software in order to execute those queries according to the selected storage technology. For example, in the case of DataPorts, the storage system is based on MongoDB, but it could be easily adopted a relational database or even an object store system. The filtering rules system, even in those cases, could be easily applied. So thank you for your attention. Any questions, please?
No. Thank you. Thank you very much, Achilles. This presentation concluded the DataPorts session, what DataPorts project is about. We try to present you both business and technical aspects of the project. We believe that we set the floor for secure and trusted data sharing that could enable the seaports transformation of the future. Thank you very much.